Okay, this is the M1 paper from June 2024. This is question number 1, the first question on the paper, and we can see this is a collisions question. We're going to be doing some work with momentum, conservation of linear momentum, and we're going to be doing some work with impulse. So let's read the question. You can see I've already drawn out a quick part of the diagram. It says we've got two particles A and B, have masses m and 3m respectively. They're connected by a light inextensible string. Initially, they're at rest on a smooth horizontal plane and the string is slack, but then to start off with, particle A is projected along the plane away from B with the speed u. So let's draw out that part of the diagram. This is before, so we have that A is set off with a speed u here. B will still be stationary at that point, and it says given that the common speed of the particles immediately after the string becomes taut is s, and it wants us to find s in terms of u. So after, what are we going to have happening? Well, let me just copy out this diagram so I'm not wasting time with my drawing skills. So afterwards, what are we going to have is that this string is going to be taut now, and both of them have got a speed of s. So this one has a speed of s, and this one also will have a speed of s. And it says, can we find s in terms of u? Yeah, absolutely we can. So we're going to use the conservation of linear momentum, which I always say in these videos, using CLM. I then write down the formula. So that's m1u1 plus m2u2. The initial momentum is going to be equal to the final momentum. In this scenario, well, m1u1 plus m2u2, we're going to get mu from A, but we're going to get 3m multiplied by 0 for B, it's not moving. And secondly, now it's up to you, you can just call this a particle of mass 4m and then do 4m times s, or if you want to, you can say it's ms plus 3ms. Either way, we're going to end up with the same thing here. So we're going to get mu is equal to 4ms here. The m's can cancel. So we want s is going to be equal to u over 4. Okay. On to part B. Part B says, find in terms of m and u the magnitude of the impulse exerted on A immediately after the string becomes taut. So what I tend to do for this one is I'm just going to focus on that part there. Let's copy that down. Let's do it here. We've got a little bit of space. And what we're going to say then is for A, well, I'm not interested in those bits there. Let's call this part B. I'm now going to decide, and it actually doesn't make any difference with this question, but I always decide that if the impulse is acting in that direction, that's going to be the direction I'm going to take as positive, but I did that last time anyway. What's the impulse on A then? Well, the impulse is always equal to m v minus u. So in this case, the impulse is equal to the mass is m. We've got everything algebraically here. V, I worked out V was u over 4 minus u then, so that's going to give me an impulse of minus 3mu over 4. And if we look at the question, because it always said it, it'll always say the magnitude. So it doesn't matter whether I worked out to be a negative or positive. The magnitude of it then is 3mu over 4 for the impulse. So relatively straightforward first question, as we would hope. Hopefully that all makes sense to everybody.